This is ME627, nonlinear vibrations. Okay, my name is ANINDYA, Anindya Chatterjee, but you can say Anindya Chatterjee if it pleases you. I am a professor in mechanical engineering at IIT Kanpur. It is now January 2021. This is an online semester, so you have to watch these lectures and see what you learn from them. My email address institutional is that, and I will send you emails from here to the course alias, which is ME627A. But you will send me email to my Gmail account, please, because search is easier there, and you will write ME627 in the subject line. If you don't do this, I do not take responsibility for reading your email. Your email to me must be at this address, and it must have that in the subject line. All right, now let us talk about nonlinear vibrations. So vibrations, as you know, there is usually some time axis, some state vibrates. It need not vibrate periodically, it need not vibrate with zero mean, there may be many degrees of freedom, whatever it is. So this is vibrations. Nonlinear has to do with the nature of differential equations governing these vibrations. You may think that, for example, after this course you will be able to solve truck vibration problems, and I am very sorry to tell you that you will not be able to do that. However, when you encounter truck vibrations, you may see some things which you will understand better if you have taken this course. It gives you some vocabulary, some way of thinking about things, but the problems we will be able to handle in this course are going to be much simpler than those problems. For example, you may be familiar with this system, but if we add here k0x cube, you may be less familiar, and your understanding of just this system will take some time, and you're still a long way from the truck. Okay, so for these reasons this course may be interesting. I personally find the subject beautiful. It will help you think in new ways, and you will learn some techniques and methods that will hopefully carry over to other subjects, and that's the best I can offer. Okay, books. Let's talk about books. So there are many books which have topics or titles like nonlinear vibrations, which are the older books, nonlinear dynamics, which are more newer books, dynamical systems, usually there will be chaos mentioned there. Okay, so many such books are there, many are available for free, some legally, some illegally. Whatever you do, those books are there. Some of the books that you may like to look for, one is by Strogatz, and this is extremely readable, but the match with the course will not be very high. Professor Richard Rand at Cornell has nonlinear vibration notes, and those are free. Nonlinear vibration notes, you can look for them on the web and find them. There is a book by F. Verhulst, which is also very good, and I will be covering material, but there are many. Okay, so there are things that the information is easy to find. Okay, tools to be used. MATLAB is necessary. You cannot avoid it. You have no excuse for not having it. You can access MATLAB online, and if you don't want to use MATLAB, drop the course. Maple does symbolic calculations. We have a minor problem here. The institute has only 10 licenses, so you will have to timeshare. You will have to try to log in when others don't have it. There are, of course, illegal versions which I cannot recommend, cracked versions and so on, but they are there. It cannot be denied that they exist. There is also the possibility that you have Maple already installed. There is also something called Mathematica, which is very powerful, and it is free and online, but I have experience with this and no experience with this, and so you can use it and it will work, and you can also do it by hand, but it will be very difficult in my opinion. But you are young and you're quick, and maybe you can do that. If you use these and you get the right answer, I will have no problem with that, and I will try to give you assignments where this is not essential, but still it will be highly preferable. So you can log into the course platform, which is Mookit. You can see I have put a forum there, and you can respond to it and let me know. This unavoidable, certain amount of effort, unavoidable. This is highly preferable, and these are acceptable as substitutes for that. Okay, so these are our tools. Now, when we say nonlinear vibrations, we will mostly be interested in nonlinear differential equations. And what are these? So let's start with a vibration equation that you are familiar with: mx double dot plus cx dot plus kx equals 0, or maybe equals f of t. Let me see here. So this is called the forcing term sometimes. Sometimes it's just called the inhomogeneous term. This is called the homogeneous part. From this equation, please remember, this right hand side does not explicitly depend on x, only the left hand side depends on x and its derivatives. This left hand part, when you pull it out, this is called the homogeneous equation. And the test for linearity, LIN, is that there should be a homogeneous part, and that homogeneous part should have the following property: if x1 is a solution and x2 is a solution, then alpha x1 plus beta x2 is also a solution. The homogeneous equation allows you to superpose. You can use superposition. If your equation passes this test, then it is linear. If it does not pass this test, then it is not linear. Oh, come on. Okay, so let me give you an example of something. so that it will become clearer. Suppose I have t square x double dot plus cos of t x dot plus 4x is equal to 32t square. Well, this is still linear. The coefficients need not be constant. They can be functions of the independent variable. That's okay. Okay, linearity has to do with how the dependent variable and its derivatives appear. So linear. Okay. Now that's one. The other thing that I want you to notice is that I could have, for example, a situation where I want to write this differential equation as a system of linear equations. So what I will do is I will say x dot equals v, and I will say t square, well, let me do it, t square v dot plus cos t v plus 4x is equal to 32t squared. And you will see that this system can be rewritten as x dot and v dot equals something that depends on x, v and t. If I say q is equal to xv, I call it my new state vector, then q dot is some function of qt. This is the abstract form of a system of first order equations. Okay, maybe linear, maybe not linear. This one happens to be linear, but it could be not linear. Let me give you another example. Let me also give you some variety with blue ink. Okay, so let us say I have y double dot plus y cube plus xy dot x dot equals 7 log x y dot, and I have x double dot plus x dot y dot plus x cos x is equal to t. Okay, very good. So now this is a horrible set of differential equations. I have no idea how solutions look like, but that's not the point. The point is I will now say q1 is equal to y, q2 is equal to y dot, q3 is equal to x, q4 is equal to x dot. Okay, so now I am defining my vector q like this, and then what will happen is this one, which is y double dot, is actually q2 dot. So I will have q2 dot plus q1 cube plus q3 q2 q4 is equal to 7 log q3 q2. So that's one equation, and I'll have another equation that looks like this. X dot is q4, so this is q4 dot, q4 dot plus q4 q2 q2 q4 plus q3 cos q3 equals t. This is my second equation, and I will have, you see, q3 dot equals q4 from here, q3 dot equals q4, that's my third equation, and I will have let me see now, q1 dot is equal to q2, and you see these four equations can be written as q dot is equal to f of qt. In this way, even if I have a system of more than one equation coupled, higher order differential equations, non-linear, coupled, whatever it is, I can write it. A very broad class of useful equations can be written in first order form so that they take this form. So this is the basic form of differential equations. When I say a system of differential equations, or when I say a dynamical system, I am talking about this. This thing is also called a flow. We are talking about this when we talk about a dynamical system. This is a smooth dynamical system. There can also be mapped or discrete dynamical systems. We will come to that in due course of time. Now, what do we know about these solutions? So here it is. If q dot is equal to f of qt and the right hand side is sufficiently well behaved and q at time 0 is equal to some vector q0. So this is the differential equation. This means it's a nice differential equation, and this is called an initial condition. This equation, this thing is called an initial value problem. This part is called an initial value problem. The initial value problem, if the right hand side is well behaved, then it has unique solutions. What do we mean by well behaved? We mean Lipschitz conditions, which you have studied, and if you haven't, study it now. You need to know this. Okay? Let me give you an example of what happens when a system does not satisfy Lipschitz conditions. So I'll give you that example here. Let's take x dot is equal to square root of x and x of 0 is equal to 0. One solution is x identically 0. Another solution is dx by square root of x equals dt, which leads to 2 square root of x equals a plus t. Initial conditions tell you that a is 0 and x is therefore t squared by 4. That's another solution. Now once you realize that there are these two solutions, then you can take this to be the time axis, take this to be the x-axis, and you realize that one solution is this solution. From this initial condition, it's going all the way like this. Another solution is this yellow solution. From this initial condition, it is this parabola. But there are other solutions. So for example, you could come along like this some distance, and then from there you could have an identical parabola just like this one. So there are many solutions. The reason there are so many solutions is that this point is included, and at x equals 0 this has infinite slope, and because it has infinite slope it does not satisfy the Lipschitz conditions. Okay, good. ODE solution using MATLAB. Okay, so MATLAB has a built-in function called ODE45. In that you should use ODE set to set tolerances. Sorry. What am I doing? Tolerances. Which includes something called relative tolerance and absolute tolerance. Set them to be 1e minus 6 or 1e minus 8 or 1e minus 10. Sorry, not like that. Here, something like that. The default is 10 to the power minus 3 or 1e minus 3, which is not acceptable for meaningful serious work. So you do that, learn how to do this, learn how to use OD45. It's a prerequisite. Okay, you can't take my course on nonlinear vibrations and say that you don't know how to solve. OD is using MATLAB, that's your assignment, you learn how to do it. There are lots of videos on the web, including something I've posted elsewhere. Figure out how to use that. Okay, now for Maple, do something like the Taylor series of log 1 plus sine x, or something for small x, several terms, and see. So then that means you've got your feet wet, and then we will see what happens. So this is enough for today's first meeting, and then we will have a discussion session and so on. I will be writing about it.